So, hello everyone, welcome back. And today, the main agenda, or you can say rather, the main aim of this video would be to solve and simultaneously also explain you that how actually this problem actually should be approached. Now, of course, if you are preparing for JEE or if you have even indulged in a bit of Olympiad, that basically a bit of advanced mathematics, then of course you might have come across this kind of problem or maybe very similar ones. And especially in it even came in JEE Advanced a few years back. Few years means around 20 years back. But anyways, uh, the thing which I wanted to tell you first, that this problem is the true definition, like exactly how you should actually approach a single problem, right? So it's a really good problem considering the fact that you need to think fundamentally. If you just see the solution, I saw one solution which is of 3 minutes, and it just did, and they just didn't even discuss any conceptual stuff or anything like that. They just went on and solved this, like without even giving us the slightest hint that how can we approach the next step. So my aim here would be to discuss not only this problem but exactly how can we approach it. So of course, before I do that and before you play the video further, first I would like to ask you to first stop and please pause the video and give it a genuine try, at least two genuine tries. Whatever you know about quadratic, and even honestly class 10 students who have been taught or who have the basic ideas of sum of roots and product of roots, they can also approach this problem. They can also easily, with a bit of, what can I say, fundamental thinking, can solve this problem. This is really not anything too out of the box, which is basically not too unthinkable, but it would be very much useful and very much handy if you first attempt it, because then only you can understand that how easy it was, right? So that's the thing. And of course, if you already know the process or already know the solution, then just see and try to learn that how should you approach this kind of problem. So with that being said, please pause the video and give it a genuine try, and let's start. So this is the problem, right? So uh, after reading all this, that okay, a b c d be distinct real numbers, and okay, these are the roots. So let me just write the what can I say, the equations once again. It's sorry, let me just use a bit more thicker pen, right? So yeah, so let's say x square, the equation is again x squared, and what is it, x square minus 2cx, right? So 2cx and minus 5d equal to 0, and the roots of this are a and b, right? So a and b are the roots of this equation, right? And again we have the other equation, that is x square minus, again just 2ax, and again just symmetrically minus 5b equal to 0, and we have been given the roots of these are c plus c and d, right? So now let's just concentrate on what we are actually to find, right? So if you're a human, right, and you at least have any bit of common sense, or even you at least appreciate beauty in the sense that okay, something, what can I say, something primitive, right? So upon the moment you see this, that a plus b and c plus d, don't you automatically, this thing, doesn't it automatically hit your mind that you need to find, you can find a plus b from here and c plus d from here, and then you can add them up? Just tell me, isn't this just very obvious? Because see, we have been given quadratic equations, and we have of course been given that a and b and c and d are the roots of the quadratic equation respectively, right? So very next thought, upon seeing that we have to find the value of this a plus b plus c plus d, the very next thing that will come into our mind is that basically the sum of roots and product of roots. Why will it come to our mind? Because that's the only relation we have, right? So upon seeing this, a plus b and c plus d, the very obvious next thing, as I mentioned, if you're a human, which you would do, you will be just doing like this. Okay, so you will calculate a plus b, from the first equation you will get a plus b equal to 2c, and from the second equation you will also get c plus d equal to 2a, right? So c plus d, let me just write c plus d equal to 2a, fine. So add them up, and you will get what? A plus b plus c plus d. So whatever the required value. Okay, so a plus b plus c plus d is equal to 2 into this is a, and this is a 2 into a plus c. So this is what we got. And if you want to further simplify, you can just go for it. Then what we are actually getting is that b plus d is equal to a plus c, a plus see. So this piece of information we got. Now see, we of course were not looking for this kind of information, of course, because what we were looking for a finite answer, right? B plus d, they are also given in the question, so of course we are not going to report our answers in that. So of course our main motive was not to somehow prove that these two are equal. However, in doing that while doing what we were asked to do, a plus b and a plus b plus c plus d, we ended up with this important result, or this result. We don't know whether we will use it or not, but of course, hopefully this piece of result which we derived will be helpful to us, right? So mm now okay, so now we have done till this. And also whenever this is kind of, you can say, a tip, or rather it's also like whenever I personally also, whenever I find this especially in a quadratic, the sum of roots and the product of roots, then simultaneously I also try to, along with it, I also try to write the, what can I say, the product of roots. So product of roots would be what? A into b is minus 5d, and C into D would be minus 5b. Now, see, of course, explicitly we don't have any particular reason to write this. Why I wrote this? Because generally, because see, I am not able to think further. Whatever I knew about the sum of product and stuff, I ended up using in this up to this result, and after this, I am kind of, what can I say? I am kind of aimless currently. Previous, my aim was to somehow get this value of a plus c plus a plus b plus c plus d, and I did this. However, it came in terms of variable, right? So now I am just sitting and thinking what else to do. And also me, as from personal experience also, and of course it is also very, what can I say, it's very intuitive that we will also simultaneously write the product of roots as well, because of course we don't have anything else to do. What else we will do, right? So so now we are sitting here and thinking that okay, AB and CD is okay. So AB equal to minus 5d and CD equal to minus 5d. Now now after you were sitting here, that okay, fine, now we wrote the product rules, but now what? See, previously, in previous case, you were asked to find the value of a plus b plus c plus d, and you added them up, and you got up to this result because a plus c term cancelled out, right? One extra a plus c term cancel out, and you got your result that b plus d is equal to a plus c. Okay. So similarly, keeping that kind of case in mind, you can say previous, it can act like a memory. So what you can do here, what you can do here is that maybe try to multiply them. Now, why multiply? Because in this case, what happened, that you added them up, of course, because of the, as the question mentioned, that a plus b plus c plus d. That was the reason for your adding them up. So once you add them up, you will see that a plus c, one term cancels out. So what if, of course, now if you add again, try to add these two equations, a b and c d, then of course you won't get anything beneficial. However, can you see that if you multiply these equations, you will get a b c d. A b c d is equal to minus minus plus, so 25 bd. Can you see it? Like, can't you just see that ABCD is equal to 25 BD? If I think my handwriting is a bit off, but please ignore that. But can you see that why did we multiply? Because of course, seeing taking inspiration from this case, we wrote this product of roots, and we were just sitting and looking that what else could be done. Of course, we use this condition of the sum of roots. Now product of roots comes into play, and similarly, as we summed up here, and one extra term got cancelled out, we also taking inspiration, or you can say, what can I say, a reference from that case, we also did this, and we ended up with the result that a b into cd is equal to 5 bd. Now one thing which people will say, that okay, cancel out bd from both sides, and then you will many solutions I have also seen that they just do like this, that ac is equal to 25, they just cancel bd on both sides. But how do you know that b or d is not equal to 0? If it is equal to 0, then your cancelling would not be valid. So what is the actual right procedure? The actual right procedure is to just bring this whole term to the other side. So what you do, instead of directly cancelling, you ac minus 25 multiplied by bd, right? Multiplied by bd is equal to 0. So we get this equation. So of course it's more like a general quadratic equation, and now we know that either ac equal to 25, from here that ac is equal to 25, or b and d are 0, b into d is 0, right? So can you see, we have somehow found a relation between a plus c, and now we got a finite value for ac, right? So we can of course directly relate, maybe a plus c and ac we can directly relate and find the value. However, we have one extra problem, is that we are also getting this case. How do we reject it? Okay, so this one is fine, that AC is equal to 25, but we also have this case. So is there any way we can reject it? Now let's move back to the question and see whether any restrictions have been given or not. Okay, that whether to reject the case BD or not. Otherwise, we have to take BD also in consideration, right? So they have given us that A, B, C, D be distinct real numbers. Okay, so these are distinct real numbers, right? So that means a distinct real number means A, B, C, D, none of them can have the same value. Let's say B and D cannot have the same value, right? So basically, each and every one of them is unique, and of course, they are real numbers also. That is also mentioned. So can you also find something similar to this? Like previously, you did this BD into AC minus 25 equal to 0. Can you do similar thing in here? That if BD equal to 0, either B equal to 0 or D equal to 0 or both 0. Now, of course, both 0. So, can you realize this is not something out of the box? This is just as you are doing, and this is just coming into your head continuously. It's not something that you should memorize or you should so called practice for it, right? So, so now we get the case that both 0. Now, of course, reading each and every, what can I say, point, or each and every word with carefulness. They have given this word distinct and they have played a game here, right? So both 0 cannot be possible. Why? Because how can b and d both be 0? It is told, explicitly mentioned in the question, that b and d cannot be the same. Hence the case of both 0 is just rejected, right? So now let's say, consider anyone. Let's say b is equal to 0. If b equal to 0, mm, can't you directly see that if any wait, yeah, so if, let's say now somehow you need to reject these two cases also, because until and unless you only end up with AC equal to 25, you cannot move further. Because if you reject it, then that would also become, what can I say, partial or incomplete or so-called cheap solution, right? So b equal to 0, what consequences will happen if b equal to 0? Now let's go back to the equation we originally formed. Let's say this. So b equal to 0, let's say put it here. And of course, if b equal to 0, a cannot be equal to 0. That means 5d minus 5d equal to 0. That means if b is 0, d has to be 0 as well for this equation to hold true. But we know, again, we know that b and d cannot be the same. B and d cannot be 0. Hence, b also cannot be 0. And of course, now you can, of course, again try for yourself. Take d as 0. If you take d as 0, put the value of d here. C again cannot be 0, so it's just 0 here. And 5 minus 5 b equal to 0, that means b equal to 0 again. If d equal to 0, b also has to be 0. But that is not possible because no two numbers are equal. All of them are distinct, right? All of them are unique. So that's how we reject this case. Now some people will directly cancel out BD from here, but of course that's wrong. We have not analyzed it. Do you realize what is the actual point of this discussion, right? So of course this is a problem which I can almost solve in 5 minutes, or might be even less than that. Because of course I have done this before, and many of you have also done this before. But the main aim was to think like this, right? So that we are suddenly going up to the mark. So now we have ended up with this. Sorry, we have ended up with this AC equal to 25. Right, so fine. Now, but now again you are stuck that I found out AC. It's just fine. But for let's say I want to find out A plus B plus C plus D. So can you see that there's an extra preference on a plus c? So basically, I know ac, I know the value of ac, and if from there I can somehow find the value of what can I say, a plus c, then my question would be done, my job would be done. How? Because 2 into a plus c would be the value of this whole number, a plus b plus c plus d. So we know ac. So now from this, using this information of ac, somehow we need to find the value of a plus c, right? So again, you are after gathering all this information, that now okay, I need to find a plus c and I know ac, you just again go back to the question once and you are thinking what you will do, right? So see, you have used the what, you have used the product of roots, you have used the sum of roots. So, and you have also rejected a particular case, and also you have gotten what can I say, a kind of equation, or let's say ac equal to 25, that kind of thing. Now you are thinking that okay, I know the value of AC. So how can I use this to? How can I? In which place can I use this to find the value of A plus C, or rather just use it? So of course, it's clear. Of course, you cannot use it here, and of course here no term of AC, like A into C, no multiplication term. So you are back to square one. Back to square one with the extra bit of information. Back to square one where? Back to the equations. And now if you observe closely, see what has happened. You know the value of AC. Can you see how AC can form? See, is the root of this equation. A is the root of this equation. Can you just put the value of A? What you will get? A square minus 2AC. Can you see? You are getting the 2AC term. Minus 5D, of course. That minus 5D term is also there, but ultimately you are indeed getting the value of AC. Can't you just directly see? A square. So what you are getting? A square minus 2ac. You are getting the value itself. 2ac minus 5d, that is equal to 0, because again a is a root of this equation, so a must satisfy. Why we did this? We did this to create the term ac. Of course, we derived the conclusion that ac is equal to 25 using this whole thing. How what use we will get that if we again try to put ac equal to 25 here? And of course, in the plus there is no AC term. So back, when you are back again to the quadratic equation, and you will see that okay, A and B are roots. That means why we are especially putting A only and not B. Again, we know the value of AC. That's why. So that's why we try to create. That is also idea, fundamental idea. We try to create what we already know, right? So x square minus 2AC minus 5D equal to 0, right? So for this equation, put c in here. So what it would give? C square, c square minus 2ac, again the 2ac term, right? Minus 2ac minus 5 minus 5b equal to 0, right? Of course, no issues up to that. Now can you see? Maybe just add them up, I guess. And why add them up? Because again, you are not subtracting, because if you subtract you will get that extra term of a square minus c square, and this minus 2ac term will cancel out, so we all need to include that in our what can I say, situation. So of course generally you just add it, right? So what you will get? A square plus c square, so minus 2ac minus 4ac minus 4ac. So of course we know the value of 4ac. What is the value of 4ac? Or rather, let's just for now let's just write 4ac. Let's not get involved too much into variables. 4ac, right? So that is 4ac. So that's fine. And what we get here is that, let's say we take minus 5 as common, and of course we are just subtracting. So minus 5 common, so b plus d. We get the value of b plus d. However, now you might again, so few people will go blank here. That okay, now what? We added them up. We tried to create the term AC, and we know this value of the 4AC. The value of 4AC we know, right? And okay, fine. There are again extra terms, a square c square minus 4AC. Now the main aim is that to move this whole thing in terms of a and c, because ultimately what we have to do, we have to find the value of a and c, or basically a plus c, to get to our answer. So turn each and every variable which is not of a and c into a plus c, to somehow find a relation between a plus c, or rather find a and c itself individually, right? So now you will use this piece of information. Can you see how it is all connecting? It is not something random. You you found out AC, and the very next thing which will come to your mind, that how can I actually implement, or where can I actually get AC and get some benefit, right? So, and again, now we try to convert everything into, as what can I say, towards a single thing, so that we can directly get some condition or directly get some value involving a plus c. So instead of, can you see, instead of b plus d, just substitute a plus c, right? So what it would be, a square plus c square, minus 4ac, minus 4ac minus 5, or rather let's say take 5 to the other side, 5a plus c equal to 5a plus c, right? So can you see, we finally ended up with, what can I say, a particular result, right? So particular result in the sense that, yeah, that all the variables are now in a and c, and hence now I can use some fact to get some knowledge about a plus c. So how can we use this, how can we use this kind of knowledge? So let's again see that how can, okay, so 4ac, so ac is 25, so 4ac would be what, just 100, right? So a square plus c square, a square plus c square minus 100, sorry, I told plus 100, but minus 100 equal to 5 into a plus c, a plus c. Can you see? Or rather, let's not do it now, because I have a better idea in mind. See, what you are seeing. You are seeing a plus c and a square plus c square and some 4ac kind of thing. So isn't the a plus c whole square thing coming to your mind? Just see, it's just logical. What you will give, a plus c whole square? A square plus c square minus 2ab minus 2, sorry, 2ac, 2ac equal to what, a plus c whole square, a plus c whole square. So try to make it. So try to make it, what we will get, a plus c. See, we already have a square plus c square, all we need is the minus 2ac term. Sorry, this is a minus c, sorry, again I messed up a bit. So that would be a minus c. So we can already create that term of a minus c, right? How can we do so? Just see me, right. So where was I? Actually, I had to stop the recording for a bit of tasks, but where was I? Yeah. So I guess we were here, right? So we were telling that, how can we create that a plus c? So one thing is that, okay, you see this, that a plus c whole square and minus 2ac will give you a minus c whole square. But can you see, if you are again just going for a minus c instead of a plus c, it would be a bit inconvenient. Why? Why inconvenient? Of course, that's again another method we can do it. If you want, then maybe I will try for that method also. But just think logically, instead of just randomly throwing hands and legs there, just think logically. We need to somehow find the value of a plus c. So won't it be better to introduce that a plus c whole square here, so that maybe some a plus c comes out common? Something, can you visually imagine that thing? That instead of randomly just doing a minus c whole square, isn't, and of course, it won't it be better that if you get all the terms into a plus c, that thing, then of course we will directly get the value of this, our required expression. So what we are trying to do is that, our first approach for this is that, what we will try to do is that, try to create a plus c whole square, right? So uh, of course we have a square plus c square, so what we need, we need an extra 2ac term. So that would be a plus c whole square, a plus c whole square, and what would be this, minus 6ac, because we added the 2, so 6ac means what, 25 into 6, whatever it is, the 6ac, let's write 6ac equal to 5a plus c, right? So now, of course, 6s is a constant. The 6 into 25 is how much? 25 these are, what, 75? 25 into 3 is 75, and 75 into 2. So 150. Right? So this is 150. So the moment you do this, can you see that a plus c whole square minus, let's say this is, let a plus c some be some equal to t squared minus, let's say, 150 equal to 5t. Can you see from here, we can find the value of a plus c? Can you just directly see? Now, of course, we could have done with a minus c also. Then it would just be again a bit of more complexity, and who knows, if we might not even get the value of a plus c which we actually required. So we try to create a plus c here instead of randomly just throwing our heads that and seeing that okay, a minus c, come to me. Instead of doing like that, we thought logically, we sat for a second and thought logically that okay, finally ultimately I need to find the value of a plus c, if not a and c individually. So now, if I can also create, I know the value of AC, 2AC and all those. So if I somehow create A plus C whole square, then I can get this A plus C thing somehow out of common, or maybe something like that similar. So what you do, you just create that A plus C whole square term. And the moment you do this, you get a quadratic. Just keep a plus c is equal to t. Of course, can it will just hit you instantly that after seeing that a plus c equal whole square minus it's some constant, let's say k, which is 150 in this case, equal to 5t. Of course, this would hit you instantly. And now what? Just factorize. So what it would be? T square minus 5t. So that means 10 or 5, right? So directly do it, right? If you do it, so see how much? Minus 5t. So that means negative difference. So subtract, and of course minus. So a plus c is equal to minus 15, or a plus c is equal to 10, right? So I hope I have done that correct. Or a plus c is equal to, hmm. So whatever be it, let me just first check that what is the coming the value, what value is coming. So we are getting that t square minus 5t minus 5t equal to what? Sorry, minus 150 is equal to 0, right? So if we factor, we get a plus c. Basically, we get t minus 10. So t minus 15 and t plus 10, right? T plus 10. Okay, so yeah. So we get two values. So either we get a plus c is equal to 15, or we just equate these two terms to 0 as we do in quadratic. We get a plus c is equal to 15, or a plus c is equal to minus 10. Now again, now can you see we are very very close to our answer. It will be any one of them. Either the answer would be minus 20, or the answer would be minus 10. Now of course both cannot be the answer, and why we will also discuss that. So can you see that we are very very close? Ultimately we are ultimatum. We are at the ultimate penultimate stage, because we have found the value of a plus c. Can you realize the whole manipulation on which we were going? This was not something out of the box, rather very visible to us. That's why I'm explaining each and every step and not just doing that solution, 3 minute solution, right? So that's the thing. Now we have got the value of a plus c as 10. Sorry, minus 10. So now what we need to do? We need to find somehow prove that only one value can exist, right? So and also one extra information, maybe you also know that AC would be 25. That's just an extra bit of information. So now you need to check the validity of all these two. So one method is you can do one thing is that, let's say you take this condition a plus equal to minus 10. So let's say a equal to minus of 10 plus c. So minus a into sorry, minus of c into 10 plus c equal to 25. So let's say you do this, right? So mm, okay, so you end up with this. Let me. I'm just now thinking. I have also not solved this problem for much longer time. So I'm just thinking what else to do, right? So AC is equal to 25 and 10 plus C. So if I just open, then minus 10C plus C square plus C square equal to 25. Okay, so minus 10C plus C square equal to 25. That means C square should be, of course, greater than 10C. And that means what? We have this to know. Oh, yeah. Another thing we can do. Forget this. We have now we can also construct quadratic with this, and we can directly check the value of discriminants, whether they're coming out to be positive or negative. Just see a plus c, what it would be, right? So a plus c and c. So we have been given the value of ac. AC is equal to 25, and we also know the value of a plus c. So do you know that we can consider construct quadratic equation if we of which whose roots are a and c. So if we consider the quadratic equation whose roots are a and c, then we get the x square minus what, 15x. x square minus 15x plus 25 equal to 0. Plus 25 equal to 0. Or if we consider this, then we will get x square plus 10x uh, plus 10x plus 25 equal to 0. Can you realize what I have done? What my main idea or main thought process behind this was that okay, I have two numbers. I somehow need to check the validity of whether both of these equations can be valid or not. So of course, I know the value of the I know the sum of two numbers. I know the product of two numbers. One thing is of course I can relate it with a plus c whole square. If I relate it with a plus c whole square, what it would be? Maybe we can also try with that also. Let's say a plus c whole square. So let's say you square both sides. So what it would be? A square plus c square, a square plus c square plus 2ab. 2ab means what? 2 into 2ac. So 50 equal to what? 100. 10 square is 100. So a square plus c square is 50. So that's fine. I have to think on this method. I don't know. I am currently not getting what we will get from this. But of course, if we check the quadratic method, however, see we have been given two numbers and we also have the sum of and product of them. So it's obvious that we can also construct the quadratic equation whose roots are a and c. So these are the two possible quadratic equations. Can't you see? And take my advice and do one thing. Try finding out discriminant here. So what would be the discriminant? B square, that means 100 minus 4ac minus 25 into 4. So basically, can you see the discriminant is coming here to be equal to 0? Can you see? Discriminant is coming out to be 0. And from here, what will be the discriminant? B squared is 15 squared 225. So that means it's root 25. It's a root 25. That means basically positive. So basically, this means that A and C here, in this case, that A plus equal to 25. Sorry, don't confuse this with 15. A plus, sorry, it is 15, not 25 again. I think I messed up. Or did I? Uh, Yeah, so AC was 25, right? A plus C was, I'm sorry, I'm just writing it wrong. So A plus C was 10. Sorry, very sorry for what I've written. I know you might have been thinking, so A plus C is 15. So A plus C is 15, right? So, and A plus C is 15 or minus 10. So, if that is 15, so 15 square is what? 225. So, basically, what I mean that the discriminant is coming out to be greater than 0. So, if the discriminant is coming out to be greater than 0, that means both A and C are distinct as well as real. However, here the roots are real. However, A and C are not distinct because the discriminant is coming out to be 0. Hence, for the discriminant to be 0, both of the roots should be equal, which is not the case as it is mentioned in the question. Sorry, we have been given explicitly in the question that these two this a b c d, all of them should be distinct real numbers, right? So it cannot be that a and c should be equal. So if a and c are equal, then only this a plus c equal to 10 will condition will hold true, right? That is the only place where it will hold true. Or one thing also, if you directly don't want to, maybe if this quadratic idea don't hit you, then you can do one thing. Maybe try to relate these two. How can you relate that c equal to 25 by a? Just substitute a plus 25 by a plus 25 by a equal to minus 10. Just see a square minus 10 plus 25 equal to 0. A square minus 10 equal to 25 equal to 0. Now just find the discriminant. See, similarly, as a satisfies, similarly c will also satisfy the same equation. Because can you see, if you also substitute that c equal to a equal to c by 25 by c, you will also end up with the same equation. So a and c both will satisfy this equation. And can you see that if both of these satisfy, again the discriminant find out here, you will again find out the discriminant to be what? 0. That means a and c are again equal, which is of course not possible. The only possible case is that a plus c is equal to 15, and we have found out the value of a plus c, and that was all required. We, for the net answer, we need to find the value of 2 into a plus c. So the answer to this question would be 30. So of course, this question could have been solved really easily by just ignoring so many steps and just doing nothing and just telling that yeah, it's ऐसे ही hota hai and all those stuff. That was the main point, that to discuss that each and every, please, of course, if I have done any calculation errors, please excuse me for that. But I hope the whole concept is clear, that how are we actually approaching the problem, right? So I hope this session was very clear to you. Please tell me if you really need this kind of session, because in general, if you see the solution, the 3 minute solution I just saw, they just did so many things which I explained. They just did in what 3 minutes, and they just wrote, kept on writing without any explaining. So that's what disgusts me a bit. But of course, what else can be done? So I hope you really really enjoyed. That was the main aim of this series or this video. So please do tell me. And also, very very similar question came in JEE, of course, JEE Advanced on 2026 most probably. So if you want, I will also discuss that, because it's again the same, or rather, we will try it for yourself. I will pin the question in the comment section, or I will rather share the link from whichever website I will find in the comment section. Just see and just apply this idea there, and you will see how much more easily you can get to the answer without directly thinking that, okay, just drop the fear and solve fundamental. That was the main aim. So that was it. So I hope, really hope that you enjoyed and learned many things. And that's all I had to say. I really have no words for it, especially after this much deep immersive session. So take care, of course, and bye bye.